Hey guys, it's Nate here. Today I want to talk about SQL window functions. So window functions in SQL are considered an advanced topic, an advanced concept, and they come up a lot during data science interview questions. And it comes up a lot during work because it's useful for solving a lot of different types of data science questions. So I've covered a few window function questions in the past videos, but this is going to be the last video in this window function series. So the way this is going to work is I will introduce each type of window function. Then I'll introduce a question, a data science interview question. So here are the 4 SQL window functions that we're going to cover today. I also split the video into different sections so you can skip around if you want to. All right, so without further ado, let's start with the first window function. But before we start, subscribe to this channel if you like this type of content. All right, so the first SQL window function is called basically a regular aggregate function. So these include average, counts, min and maxes, things that you would do in the select clause. Now the difference is, and why you would want to use this window function is if you want to take these aggregates like an average or a count, but group them by different categories in a column. So one example of that is grouping by month, if you have the month of a year. Another example is grouping by countries or grouping by states. All right, so let's take a look at this question here. I'll show you how to implement an aggregate window function to solve this question. So I've linked this question in the description below. So if you want to follow along with me, go ahead and click into that platform. All right. So this question is called distance per dollar. You're giving a data set of Uber rides with the traveling distance, this column here, distance to travel, and the cost, monetary cost for each ride. For each date, find the difference between the distance per dollar for that date and the average distance per dollar for that year month. The distance per dollar is defined as the distance traveled divided by the cost of the ride. All right, so I won't read the rest because the meat of the question is right here. Let's just take a look at the data really quick to see what this question is even talking about. All right, so what this question is basically saying is that you have a table with Uber rides, right? And so in this table, you have the distance per ride here. This is the column, and then the cost per ride. So a metric that you want to create is actually distance per dollar, which is just distance divided by cost. Basically, the ratio between these two columns is distance per dollar, right? And so what you want to then do is using this request date, what the question is asking you to do is for each date, find the difference between the distance per dollar for that date and the average distance per dollar for that year month, right? So what we need to do is actually extract the month from this date, the month year from this date, and then find the average, right? That's actually really difficult to do without a window function because you want to take the average of every month. So just to make it clear, this is what you're trying to find. So what you're trying to find is the distance divided by cost, so the distance per dollar, minus the average distance per dollar for that month, right? And you're trying to do this basically for every date or for every Uber transaction. So you can have a table that looks something like this. So for January 1st, 2020, it's 5 miles per dollar. And then for January 2020, for that entire month, it averaged out to 4 miles per dollar. For February 1st, 2020, we have 5 miles per dollar again. And the average for the entire February month was 3 miles per dollar, right? So this is actually very difficult to do in SQL without a window function. So let's actually show how I would implement something like this. All right, so in this example here, we have this subquery here, right? So all I'm doing is I'm taking all of the columns, and then I am extracting the month year from this request date that you see in this bottom part here. Right, so I'm just grabbing January 2020, and then when you go down, I'm grabbing February 2020, and we're calling this request month. All right, and then I'm taking the ratio of distance divided by cost to give me distance to cost, so that's the same as distance per dollar. So this is going to be the subquery, and then when I apply the window function on the subquery, I have the request date, I have the distance to cost, which is again this ratio here, distance divided by cost. And then I'm taking the average. So this is the regular aggregate function that I was talking about. It could be average, count, it could be min or max. We're taking the average. So we are averaging the distance to cost over partition by. So that just means group. Like, what are we grouping by? We are grouping by the month, right? So we're taking the average again of distance to cost and then taking the average only of the values in that month. All right, so then you get the average distance to cost. So now when you run this query, you basically get the request date, the distance to cost for that date, and then the average distance to cost for that month. So this is obvious here because you have January 2020, you have two different distance to costs for the two different dates, but you have the same average monthly distance to cost. And then when you look at February 2020, it's the same thing. You have two different distance to cost, and then you have the same average distance to cost here. And so this is exactly what a window function allows you to do. In this case, take the average, group it by month, and put it as a third column. This makes the calculation when we take the difference between this and this super easy because all of the values are already on one row. That's how SQL works. SQL works basically if all of the values are in one row, it can do any calculation really simply and really fast. All right, so now let's go ahead and just review the rest of the solution here. What I showed before was this entire subquery here. And all we want to do is take the difference between the distance per dollar minus the average distance per dollar for that month. That calculation is right here. All right, we're calling it mean deviation. So when I run this, for every date, as you see here, we get the mean deviation, which is really just the distance per dollar for that date, this date, minus the average distance per dollar for that month. So that's the first SQL window function. We call that the regular aggregate function. And again, it's just making use of simple aggregation functions like average, count, min. Right, the second SQL window function is called ranking functions, and it's exactly what you think it is. It's used to rank rows. So this window function will essentially add a ranking index as a column. So there are three different types of ranking functions. There is rank, there is rank dense. So these are essentially ranking functions that differ slightly. I have some resources in the description that explain the differences between these two. And then the third ranking function is not necessarily a ranking function, but it's a way to number the rows. So basically adding an index as a column to your table. All right, so let's just take a look at one data science interview question called unique salaries here. And let me then explain how I would use one of these ranking functions to solve this question. So this question's by Twitter. It's called unique salaries. It says, find the top 3 unique salaries for each department. Output the department name and the top 3 unique salaries by each department. All right, so let's just take a look at the data real quick so I can show you exactly what I mean. So this is essentially an employee table by Twitter here. We have two columns that we care about, department and salary, right? We want to grab the top 3 salaries by each department. We can't necessarily just do a limit 3 in the SQL query because it's just going to then grab the top 3 salaries in the entire table. So we need a way to be able to find the top 3 salaries split by department here. So we need a window function here to be able to group by department and then take the top 3 for every single department. So let me show you how that's done. All right, so from the table, all I really care about is the department and salary columns of the table, and I'm throwing everything else away. What I'm doing here in this subquery is just deduplicating the data. That's what this group by does. In case there are duplicate salaries by department, I'm basically just deduplicating that so it's all unique salaries and departments, right? So that's not the important thing here. The important thing is implementing the window function. We are using rank. So it will add a rank by department and salary. And then what I'm doing is then partitioning by or grouping by department. And then I'm ordering the results by salary. So highest salary first, all the way down to lowest salary. So what that actually leads to is something that looks like this. So I have the department here, and I have the salaries ordered from highest to lowest. And now I have this rank, right? This is what the rank window function did. It added a rank based off of highest salary to lowest salary. So then I have 3 in audit, I have 3 in management, and then I have 7 in sales. And so you can see for every department, the ranking restarts. So this is exactly what we want. So now it's actually really easy to do a limit 3 by this rank ID. And so that way I can take the top 3 sales salary and then throw the rest away. All right, so here's the solution to get the top 3 unique salaries by department. So the query that I showed before is now my subquery here. And then in this outer query, what I am outputting is department, salary, and the rank. And the logic here is where rank ID is less than 4. So I just want to include in my output just rank IDs 1, 2, and 3. So that results in something like this. So audit, we get the top 3, and you can tell that it's the top 3 because the rank IDs are 1, 2, 3. It's the same for management, and then it's the same for sales. So anytime you want to get a ranking by group, you want to use this window function called rank. All right, third SQL window function. It's really just one function. It's called Ntile. You can actually customize it to go from 1 to 100, which is a percentile, or 1 to 4, which is a quartile, but it will basically divide up your data based off of the number of bins that you want. So let me show you a data science interview question here, and I'll show you how we can implement an Ntile window function. This question is from Netflix. It's called Top Percentile Fraud. It reads, ABC Corp is a mid-sized insurer in the US, and in recent past, their fraudulent claims have increased significantly for their personal auto insurance profile. They developed an ML-based predictive model to identify propensity of fraudulent claims. Now they assign highly experienced claim adjusters for the top 5 percentile of claims identified by the model. All right, so your objective is to identify the top 5 percentile of claims by each state. This is what makes it tough. Like to get the top 5 percentile, you would probably use a window function anyways, the Ntile window function. But now you then have to group by each state. That's what makes it a little bit more complex. So let me show you what the solution is, and then let me just explain through what that solution means. All right, but first let's just take a look at the underlying data. So what we have essentially is policy number, the state, the claim cost, and the fraud score. We only really care about fraud score and state here, right? So we need to take basically the top 5 percentile in fraud score. So 1 would basically be the best, 0 would be the worst. We need some sort of percentile function, so Ntile, to then give us what the top 5 percentile would look like. So we need to create a new column here that will just give the percentile based off of the fraud score and then grouped by state. All right, so this code should do it here. So what I'm doing here is basically saying that for the entire table, just output everything. That's why I have this asterisk here. So I have all of the original 4 columns. And then create this percentile column here where I'm taking the Ntile 100. So 100 just means that I want 100 bins. So that's equivalent to saying I want the percentile. If I put a 4 in, it's going to bin the data into 4 buckets. That's what a quartile is. Another common way to bin data is by decile. That basically means that we have 10 different buckets, all right? But in this case, we need percentile, so we have 100. It goes from 1 to 100. And then we have a partition by state. So we're basically just grouping all of our percentiles into states. So every state has their own percentile calculation going on, right? And then order by fraud score. So let me show you how this actually works when I implement this. So again, we have the 4 original columns here, and then this percentile column, which basically is telling us that this is the top percentile of fraud score. It's the highest fraud score for the state of California. This fraud score here is the 2nd percentile. So it's basically like the second best in the top 2% for the state of California. So it goes on and on until we reach another state. So on the 99th row, we reach the end of California. Now it's jumping to Florida. And then the percentile calculation restarts, right? So this is basically saying for this fraud score, this is the top 1%. The top 2% is this fraud score right here. So now all we need to do to get the top 5% is just limit the rows to the top 5 for every single state. So in order to do that, we have this code here, which is my previous query becomes a subquery. And then we have this where clause in the outer part of the query where we just want to output the percentiles 1 through 5 and then just filter out the rest. So this is a really good example of why and when you would want to apply a Ntile or a statistical window function. Anytime you want to take a percentile, a quartile, or a decile, you want to use this Ntile window function. All right, last SQL window function. This one is probably the most common used window function for data science problems or for data science interview questions. It's handling of time series data. So again, it's not only a very common question that you'd find in a data science interview, but you would use it almost daily when you're on the job. And so once I dive into this question, it's going to be very obvious why this is probably one of the most useful window functions out there. All right, so this question is by Airbnb. It's called Growth of Airbnb. Estimate the growth of Airbnb each year using the number of hosts registered as the growth metric. The rate of growth is calculated by number of hosts registered in the current year minus the number of hosts registered in the previous year, and then divide that by the number of hosts in the previous year. So let me show you why this is hard to do without a window function. So let's just take a look at the data real quick. So this is basically a transactional table here of searches with a lot of columns. The only column we really care about is host since. This is basically a timestamp of when the host registered to be a host on Airbnb. So in terms of calculating a growth metric using this column, what we want to do is just count the number of hosts that have registered in the year we care about and then compare it by the number of hosts that have registered in the previous year. So let me show you how I would solve this question using a window function. Okay, so this is a query right before we add in the window function. Let me just show you why this window function would be very useful. So all I'm really doing in this subquery here is extracting the year from that date and then counting the number of hosts that we have for that year. So what we have basically is the year and then the number of hosts that have registered in that year. So 2009 we had 2 hosts, 2010 we had 4 hosts, and it grows and then it looks like it kind of declines. But what we want to do is generate a calculation where we understand the growth year over year, right? So from 2 to 4 is basically 100% growth. From 4 to 9 is over 100% growth. And so we want to be able to communicate that using a SQL query. How do we do that without using a window function? It's really hard in SQL to take values from 2 different rows and perform a calculation without using a window function, because what you want to do is actually have all of the values in a single row to then perform that calculation, right? So if we add the window function here as the 3rd column, so what I'm using is called a lag function. So what this does is it will take the current year host, which is this column right here that I have in the bottom. And so if I am on this row here, 2010, current year host is 4, the lag and then this 1 value here will basically just go to the previous row, right? So then it will go to 2009 and take the value 2 and put it as a 3rd column. And then what I'm doing is I'm just basically doing this over the entire year column here. So I'm not grouping by or partitioning my data in any way. I'm just going to perform this lag calculation over the entire year column, basically over all of the years. So now you have a 3rd column. It's a count of the previous year's host count. So we have 2 here that corresponds to the above record. And then this 4 here corresponds to the previous row, 4. So now you have all the data you need to implement the growth metric formula all in one row, which makes it super easy for SQL to implement. And so the implementation is going to look like this. So the previous query again becomes my subquery here, and I am then outputting year, the count of current hosts for that year, and then the count of the previous year's hosts. And then the growth metric calculation or formula is in this fourth line right here. So when I look at this column here, estimated growth, this makes a lot of sense to me, right? If the current year host is 4 and last year was 2, that is a 100% increase. So again, this is a very useful window function. It's used a lot in data science because you're almost always trying to find some sort of percentage growth or some sort of like rolling average or something where you need to compare data points from one time period with another time period. And to do that, you can use this lag function here, or if you want to look forward in time, you can use the lead function. But this is a really common window function that you would use almost daily on your job as a data scientist, as well as what they would ask during data science interviews. Okay, so that concludes 4 SQL window functions that are very common, not only in your daily work, but also asked during interviews. So it's really important to understand when you would want to use these functions, why you want to use it, and also how all of the data is actually manipulated behind the scenes to get you what you need to solve the problem. So I have a few resources for you. So all of these questions that I went through, they're all linked in the description below. There are also video explanations of how I solved those questions line by line in the platform as well. All right, so that's it for window functions for now, at least. I'm going to move on to a different concept that you guys might find useful in your future data science interviews or in your daily work as a data scientist or as an analyst. So if you like this type of content, please subscribe to my channel. You'll be alerted whenever I release a new video, usually about once a week.